Hi, my name is Kanchan Vaikar, and I'm a solutions architect at AWS. And it's my pleasure to host David Banks from Koch Global Services, who is going to share their journey, how David and his team enables secure and compliant AWS workloads in over 640 AWS accounts via a self-service catalog of secure products. And then I'll dive deep into how such a catalog can be set up at an enterprise level. So, without further ado, let me hand this over to David.
Okay, well, thank you, Kanchan. And hello, everyone. I hope you're doing well today. As Kanchan just said, I'm Dave Banks, and I'm a cloud engineer with Koch Global Services. I'd like to start with a brief overview of Koch Industries so you get an idea of who we are and what we do. We're one of the largest privately held companies in the United States, with over 130,000 employees across more than 70 countries. I work in the company headquarters, which is in Wichita, Kansas. One of the things that sets us apart from other large enterprises is our implementation of market-based management. This is a set of principles and dimensions that we use to guide everyday decisions and foster success. Our CEO, Charles Koch, has written 3 books detailing market-based management, and they are recommended reading. Koch Industries is made up of many different businesses across many different individual industries. Some of our more well-known businesses that you may have heard of are Georgia Pacific, which makes products such as Brawny paper towels, Dixie cups and plates, and we also make building construction materials like plywood and drywall. Flint Hills Resources handles crude oil pipelines and refineries where they produce different types of fuels and related products. Molex makes all kinds of electronics connectors and integrated electronics products. So there's a good chance you have a Molex connector in your cell phone or laptop that you use every day. Koch Ag and Energy Solutions produces plant fertilizers and other necessary resources for agricultural purposes. Infor is our most recent major acquisition. They produce business applications, ERP software, and analytics solutions used in many businesses and industries around the world. The company I work for, Koch Global Services, provides services such as IT, accounting, and facilities for these and the rest of the Koch companies. So, why is self-service important? In a company the size of Koch Industries, it's imperative that we're efficient. Koch companies need the ability to quickly stand up infrastructure in a secure and standardized manner within AWS. With an application landscape that surpasses 3,000 apps across more than 640 accounts and growing, we need to be able to scale our AWS Service Catalog offering to meet the needs of an ever-growing cloud footprint. As a small platform team of only 6 members that supports the 12 major Koch companies, not to mention the many smaller Koch companies that also demand our attention, we realized early on that manual management deployment was not going to scale. So with this in mind, we developed a hub and spoke model of deployment that has allowed us to scale and more easily reach our end users. Our end users are developers, DBAs, data scientists, and IT support staff, and they number over 1,000 across our 640 plus accounts. Using AWS Service Catalog together with CloudFormation stack sets and AWS organizations, we're able to easily provide solutions to our end users, which is a downstream effect for tens of thousands of consumers across our enterprise. Now, let me take you on a journey from where we started to where we are today. Back in February of 2017, our business need was to get our applications into the cloud so that we could decommission aging physical hardware in our data centers. Koch Cloud was born, and it was the Wild West. We had yet to set up many guardrails, and standardization was still a ways off. Ensuring that customers were adhering to company security baselines in their EC2 deployments was nearly impossible. Over the next few months, we realized that to be successful, we needed to standardize and centrally host our EC2 offering. So we developed curated AMIs that have all our company's security baselines baked in and began offering a service catalog portfolio of Windows and Linux instances to our customers. But it was a manual process. At that time, we only had about 45 accounts, but managing different templates to accommodate different domains and business-specific configurations was already a headache, even after we created a set of custom scripts to help in our deployment. Then in May of 2018, we enlisted Carlos Tagles and Kanchan's help to build a hub and spoke model so that we could more easily meet our growing number of accounts, which all needed our service catalog portfolio. This was a game changer, in that it allowed us to templatize our deployment and reach all of our accounts with their specific needs at once. We then started adding new offerings in our portfolio the following year, such as a Zscaler solution that enables our customers to reach internet-facing endpoints in AWS accounts that have no connection back to the Koch network. But let me take a step back and talk about our EC2 offering for a minute. One of the major benefits is that our customers need minimal training in order to use Service Catalog and launch EC2 within their own accounts. In the old days, a customer would submit a request to our delivery team and then wait for at least a few days, and then be presented with an essentially immutable server in a data center. Now, customers can answer a few questions in a templated form and be using their domain-joined server within 15 minutes. We have a standard offering we present to our customers, which includes many different versions of SQL-baked Windows servers, as well as the standard Windows offerings. We also provide Red Hat Enterprise Linux and Amazon Linux 2 options. All of these curated AMIs are built with our security baselines pre-baked into the image, so that customers don't have to worry about installing anything after they launch. These EC2 builds also include a set of required tags that are applied to each instance for accounting and operations purposes. And through the use of template constraints, we're able to ensure that instances are launched in the correct VPC with the correct subnets and security groups available. And we're able to provide all these things to users with least privileged access to other resources in the account. With our hub and spoke model of deployment, we're able to use company-specific templates to configure our Service Catalog offering in each account. That means we only need to maintain one portfolio, which we can then distribute to our 640 plus accounts. Using CloudFormation stack sets, we maintain company-specific templates, which are used to configure the portfolios in each of our accounts as needed. In this way, for example, a Georgia Pacific end user can launch an EC2 instance that is joined to the correct domain and is fully configured out of the box for that specific company's use case. Another huge benefit we're realizing is the integration between CloudFormation stack sets and AWS organizations, which Kanchan will cover in depth in just a few minutes. Our company-specific stack sets are deployed to targeted OUs within organizations. Using these services together, all we have to do to deploy Service Catalog in a brand new account is drop that account in a specific OU, which triggers an action in stack sets to build and configure the portfolio in that account. So it's a fully automated, secure deployment at this point, which is a much better place to be than back in the Wild West. And now, I'll send it back over to Kanchan to dive a little deeper into these architectural designs. Kanchan?
Thanks, David. As David mentioned, enterprise self-service goals are to accelerate cloud adoption while meeting enterprise requirements. And AWS Service Catalog provides you the capabilities you need to set up self-service for your enterprise. It has concept of two personas: end users who request AWS resources to deliver applications, to improve business processes, and to innovate, and organization CCOE team who has requirements to ensure that AWS resources are standardized, tagged, and are compliant with organizational policies. And AWS Service Catalog sits in between. It enables faster time to market for end users and compliance and standardization for organizations. So let's see how it works. Administrators create standardized products, which when deployed creates compliant AWS infrastructure. These products are put inside a portfolio and access is provided to appropriate end users. And then end users open AWS Service Catalog console and request a product to be provisioned. Let me elaborate each of these concepts. As CCOE team, you want to control exactly what gets deployed in an AWS account. And that's what you do via products. You bake security, organizational requirements, and best practices into a CloudFormation template and you put that into a product. A product is at the core of the catalog, and a CloudFormation template is at the core of the product. These products, when deployed, become provisioned products containing AWS resources, such as EC2 instances, an RDS database, or an entire application. Basically, anything that was coded in the CloudFormation template of the product. These products also support versioning, tag standardization, and service actions. Administrators can go to products under administration in order to browse different products which administrators have created or have copied from Getting Started library. You'll also be able to see the product versions available by choosing the specific product. You can see that there is a version available over here. You can create a new version by clicking on the create new version button, or you can deactivate or delete existing versions. A product version has a template associated with it. You can see that this is a CloudFormation template for a model package from AWS Marketplace. And you can see that this particular template actually creates a dynamic model from the static model available in AWS Marketplace. And it also creates an endpoint. So when you execute this template will stand up an Amazon SageMaker endpoint on which you'll be able to perform an inference. You can also see the different portfolios this product has been added to in the Portfolios tab. And you can also see the tag options associated with this product. AWS Service Catalog makes it easy for administrators to create products via Getting Started library of well-architected products. Browse portfolios that have been made available to you. Choose products which meets your needs. Customize and ensure that the templates configured as part of your products meet your organizational policies, and then distribute them to your organization via portfolios. Once you have defined products, you want to control which users deploy which products, and you do this via portfolios. And in my experience, I've seen administrators creating 4 types of portfolios. A generic portfolio for larger sets of technical groups. For example, such a portfolio might let all technologists deploy a compliant T2 micro EC2 instance. I also see team-specific portfolios. For example, an advanced team deploys microservices, hence needs DynamoDB, Fargate, ECS, and EKS products. And then there is another team which primarily deploys RDS, EC2, and S3 buckets. Then there are role-specific portfolios. For example, data scientists might get to deploy a small EMR cluster whenever they want. And then there are line of business administrators with higher permissions who might deploy an AWS Marketplace product or might even create an AWS account. And often, administrators want to restrict users' permission to underlying services itself and make Service Catalog as the only way for users to request and manage resources, and admins do that via launch constraints. For example, as an administrator, I don't want to provide my users permissions to launch EC2 outside Service Catalog. So I take away their run instance, start, stop instance, and other EC2 related permissions from this user. Then I create an IAM role with these permissions and configure it as a launch role for specific product inside the portfolio. So whenever users request the product, the launch role configured in the portfolio is used by the service to run the CloudFormation stack. And that creates compliant AWS resources such as an EC2 instance. And users also manage their own EC2 instance via service actions, which internally would use launch role. It is a best practice to create standardized products by making them user, team, role, account, and region agnostic. And after you create such a product, you apply restrictions on input parameters of product's CloudFormation template at a portfolio level via template constraints. This way, administrators have to maintain less number of products while ensuring that configuration compliance is being managed at a template constraint level. In AWS Service Catalog console, in portfolios under administration section, AWS Service Catalog administrators can see local portfolios and imported portfolios apart from Getting Started library. To create a portfolio from console, they can click on this button and follow wizard. Now let me show you a sample portfolio that I've set up here for the analyst team. You can see that I have a bunch of products over here. I've also configured launch constraints and template constraints for a specific product. I've also given my end user access to this particular portfolio, and I've configured tag options for the portfolio as well. Administrators set up tag options library and configures product level, portfolio level, and account level tag options. And when user deploys a product, runtime tags, product tags, portfolio tags, and auto tags are applied automatically. And then there are other features such as ability to monitor budgets at a product or a portfolio level, ability for managers to get notifications whenever an expensive resource is being provisioned or terminated, ability for line of business administrators to configure rules across multiple accounts, and ability to use Terraform to provision resources via AWS Service Catalog, and custom branding with your logo and color scheme. So, to recap, administrators create compliant products, set up service actions via SSM automation documents, create portfolios based on different needs, adds constraints to portfolios, sets up budgets, associates tag options, and finally, provide end users access to these portfolios. Now let's see how end users deploy or provision products from the catalog. So administrators set up the catalog, and then end users would open AWS Service Catalog console, and under product section, they'll be able to see all the different products that are available to them from different portfolios. Here, they would be able to select a product and then click on launch product in order to deploy the product itself. In this wizard, they need to enter all these different parameters and then click on launch product button. Once they click on the launch product button, they'll be able to see the product launching in this particular screen. The CloudFormation template execution itself may take a few minutes. You can see that the status of this product has changed from in service to available, which means that the CloudFormation template configured as part of the product has executed successfully. And since this product template actually creates an Amazon SageMaker endpoint from an object detection ML model from AWS Marketplace, you are able to see an endpoint created in Amazon SageMaker console from this AWS Service Catalog provisioning request. So in short, end users browse catalog, choose product, specify parameters and runtime tags, and deploy them via console or API or AWS CLI or via CloudFormation itself. In fact, users also compose applications from various products available to them in such a way that dependencies are injected by passing the output of the first product as an input configuration to the other as shown on the screen. If administrators have set up ITSM integration with tools such as ServiceNow, BMC, Sharewell, or Jira, end users request products via the interface of the tool. Now let's look at different design patterns which administrators can use to manage catalog at an enterprise level. CloudFormation resource types are available for AWS Service Catalog, which let you standardize and curate catalogs while having an ability to reproduce the same catalog elsewhere. Entire catalog can be set up by CloudFormation template. You can see that by writing these few lines of code, I was able to create a portfolio, grant an end user access to the portfolio. I was also able to create a product and then add that product to the portfolio. I was also able to define a template constraint. I also created an IAM role and configured it as a launch constraint. I can also create tag options and then associate those tag options either with the product or with the portfolio. And such a catalog can be managed in a GitHub or code commit repository. A code pipeline can be set up in such a way that every time the administrator makes any changes to the template gets validated using tools such as CFNNAG or TaskCat and gets delivered into a versioned S3 bucket. A CD pipeline can then pick up the template and run a CloudFormation stack to deploy the catalog in one or more accounts. AWS Service Catalog is a regional service, and CloudFormation stack sets can be used to deploy and maintain same catalog across multiple regions. Catalogs can also be set up in such a way that they are fully controlled from a different account via portfolio sharing mechanism. You can add, update, remove products or versions in a portfolio in the hub account, and it will automatically become available in all the spoke accounts in the imported portfolio instantaneously. And this is exactly what I'm going to demo you next. I've set up a service managed stack set in my management account, which automatically creates end user roles, appropriate launch roles, and stack set execution role in an account as soon as an account is added to an organization or an organizational unit. This would let me centrally manage end user and launch IAM roles, and stack set execution role would enable me to manage my spoke specific portfolio configurations from a central hub account. So let me show you how I set up these stack sets. You can see that I've logged into my AWS Organizations Management account and I've created this service managed stack set, which would automatically deploy stacks as soon as a new account enters an OU or an organizational unit. This stack set deploys a stack set execution role with a trust policy for my designated hub account so that I can control portfolios from my service catalog hub account. You can see that when I created a new account in my OU, this stack set automatically deployed the stack set execution role. Similarly, I have another service managed stack set with automatic deployment set up that deploys end user roles and launch roles. My data analyst end users would be assuming this role while accessing the spoke account, and the SageMaker launch role would be configured as part of the portfolio as a launch constraint role. Next, you designate one or more accounts as the hub account in which you create products and manage your portfolios. You then create the portfolio and share it with another account. And by using delegated admin functionality, you can share the portfolio with an OU or an organization. Let me show you my hub portfolio, which I've shared with an OU. I'm using this account for managing my portfolios. Now let me show you what a hub portfolio looks like. You can see that it will have one or more products. You can also see the template constraint associated with this portfolio. You can also see that I've configured a launch constraint. However, I've configured it using a role name instead of role on, so that an IAM role with the same name in the recipient account gets used during the product provisioning. You can also see that I've not given access to any users who are local to this account. However, what makes this a hub portfolio is the portfolio sharing mechanism. You can see that I've shared this portfolio with an OU. And now I'm in the spoke account, and you can see that this spoke account, which is part of the OU, automatically gets this portfolio shared from the hub account. You can see that the portfolio access has not been granted to any end users, and also there are no tag options configured. The AWS account I just showed you as a hub account was not my organization's management account. I followed the steps shown on the screen to set up delegated admin permissions for my hub account so that I can share my portfolio with an OU or an organization. And then, with the stack set executed from the hub account, I added tag options to the portfolio and granted end user an access to the portfolio. In this case, my end user is a data analyst who has no SageMaker or AWS Marketplace access and yet is going to deploy an ML model via AWS Service Catalog. Let me show you. We can see that in the Hub account, I've set up a CloudFormation stack set to provide my end users access to the imported portfolio. I've also created a tag option and I've associated a tag option with the portfolio. You can handle account specific and region specific customizations via mapping speed. So in short, from Hub account, I have set up my Spoke account. Now let me switch to my Spoke account and show you how it looks. You can see that the portfolio does not appear in the local tab. Instead, it appears in the imported tab. This is because this portfolio was shared from the Hub account. You can see that the cost center tag option we created via CloudFormation has been created, and it has also been associated with the portfolio. And the CloudFormation also has granted the access to the end user role to this portfolio. We can also see that the imported portfolio inherited both launch constraint as well as the template constraint from the Hub portfolio. And it's all that's required for enabling my end users, data analyst users, to deploy the product. So let me switch to the end user role and show you what it looks like. So when I switch to end user role, you can see that I have access to deploy this product via AWS Service Catalog. And data analysts will be able to deploy the endpoint from this product just like how I did a few minutes back. And that really completes the end-to-end demo I wanted to cover today. So to summarize, I created a service managed stack set with automatic deployment to create required IAM roles. And then I configured delegated admin for my Hub account, and I created a portfolio and I shared it with an OU. And then I granted end users access to these portfolios in the Spoke accounts. And finally, my end user was able to launch products available to the end user via the portfolio in a governed and compliant manner without having access to the underlying AWS services. And here are some of the best practices which I would recommend you to follow while setting up your catalog. Create region, role, team, account, and user-specific, user-agnostic products. Manage your customizations via mappings, conditions, template constraints, and tag options. And apply design principles that work for you. Here are some codes which David shared, which clearly highlight how setting up self-service via AWS Service Catalog can help you scale standardization, security, and governance in your organization. And as a next step, I would recommend you to explore all these resources available for you. And if you still have a question, please feel free to get in touch with AWS Service Catalog team on the email shown on the screen. And most importantly, secure and standardize via AWS Service Catalog so that your organization can innovate on your behalf. And at this time, I would like to thank you for attending our session today. And a special thanks to David for sharing his experiences with us.